Hey everyone, welcome back to another episode of whatever this is. Sorry about being very off schedule, if anyone's even watching. I've been quite busy, I've been sick. I'm so sick of being sick. Like, I feel fine, but the congestion and stuff, it's just like not going away. And I've just been really busy onboarding for work, and I've been doing a lot of reading and researching and soul searching and all the good stuff. So yeah, today I'll just talk really briefly about something I learned the other day that I thought was interesting, and I related it to a quote by Shakespeare, which everyone knows from Hamlet, where he says, "There's more in heaven and earth than is dreamt of in your philosophies." Basically, it just means that, the universe has more in it than is conceived of in the human mind. Like, there's more to this world, this reality, than we can truly understand. And I think something I learned about whilst I was learning about how ChatGPT works, and neural networks and large language models in general, is that what's so interesting about them is that they currently don't have the capacity, despite their level of sophistication, they don't have the capacity to solve problems that we kind of can't solve. That's not strictly true, but there's this thing called irreducible computation. It's sort of a subset of something I'm obsessed with, which is irreducible complexity. The idea is that nature has an irreducible complexity to it, and even a lot of human systems have an irreducible complexity, where when you remove any one component, these complicated systems fall apart. Like, if the Earth was however many degrees closer to the sun or further away from the sun, we would either all boil or all freeze, things like that. Or in molecular biology, there's so many examples of things that are so tightly orchestrated and calibrated, that if they were not, in perfect alignment, your cells would break down or basic biological functions wouldn't work. But in ChatGPT and neural networks, the way that these things work, it seems to me, from my very bare bones understanding, that essentially you calibrate what's called the weight, which is how many neurons are connected to any given neuron. So that's the neuron's weight. I thought of it similar to atomic weight, where atomic weight has, say it has an atomic weight of 5, it means there's 5 electrons on it, which means it can connect to 5 other atoms. This is a similar principle, whereas a neuron that has only one connection has a weight of 1. If a neuron doesn't connect to anything, it's got a weight of 0. If it's connected to 5, it has a weight of 5. And basically, I thought of it as like a pachinko machine, where they drop in the prompt. The prompt goes through all the neurons, and then it comes out. And it's a little bit of a black box, meaning we don't fully understand exactly what it's doing. So what you do is you know what the answer is. You have a large data set, which you've given to this network, and then you drop your prompt into the pachinko machine, and then you look at the output and you see if the output's right or wrong. And then you adjust the weights. I don't know the mechanism of how they do that, but you adjust the weights, and then you see if you're closer or further away from the outcome. And as you get closer, you just keep adjusting the weights, calibrating until you get to the right outcome. There's something like, I'm going to get this number wrong. Maybe if I can be bothered, I won't be bothered editing this, so I won't bother uploading the real number on screen. Maybe I'll write it in the video description. But there's something like 700 or 75, it's either 750 or 75 or something billion neurons in this network, which is a ridiculously high number, obviously. And so what happens is we don't follow what each neuron's doing, we just adjust the weights. And it's emulating somewhat how a human brain works, with a similar amount of neurons and stuff. So the problem is that there's a problem which we don't know the answer to, and we can't compute it in steps, like significantly small enough steps. This is where computational irreducible computation, whatever, comes into it. You drop the prompt into the pachinko machine and you don't know if the answer is right because you don't know what the answer is. And to check if it's getting the right answer, you have to follow each step, and it's not practical to look through 750 billion steps of computation manually. And it seems like that's the only way to do it. And anyway, the point is bringing this back to the Shakespeare quote, "There's more in heaven and earth than is dreamt of in your philosophies." It seems that like these large language models, these networks, are capable of doing everything that a human does to a human-like level of quality, right? You know, some stipulations and addendums there needed, but whatever. But it does seem like that doesn't mean they can just solve every problem in nature. They can't like compute, well, yet. I'm sure, you know, scale. With these models, you scale them up, they just seem to become more sophisticated. I don't know if there's like a hard limit to that or what, but it's interesting. And I think it remains to be seen where this will go. And also, I really don't know what I'm talking about after a certain point. This is all stuff I learned from an article by a guy called Stephen Wolfram. Stephen Wolfram is a like very prominent AI researcher, computer researcher, scientist in general, data scientist. You know, quite brilliant. Like, he's got many publications across many fields. He's really he's really got quite a prodigious understanding of these things, apparently. But yeah, it seems like, you know, just because we make an AI that's sophisticated enough, unless it gets to the point where it's able to teach itself things and know if it's right or not and adjust its own weights, it doesn't, and then like go through and see what those individual neurons are doing and go through all the computations. It doesn't seem like an AI will just be able to like solve faster than light travel, or like explain like a full theory for how the brain and consciousness operate, accounting for all the data, or like a theory of everything necessarily. These are things which will possibly still elude us. I don't know if this is like a hard limit or if this is just like a matter of scale. Sorry, an ant bit me. One of the co-founders of OpenAI, who I forget his name, I'll put that in the description too. Bloody hell. He said that scale doesn't actually solve anything. Like, he says, like, even if you get the systems we have now 100 times scale them up, it'll be like amazing, obviously, and it'll do a lot of things, but it's not going to actually represent like a paradigm shift in AI. But it kind of seems like he's an exception to the usual consensus. But then again, like, a lot of these people maybe have a financial investment in pretending like there's no upper limit to what these models can accomplish. But also, I actually just don't know enough. Like, I'm actually like really amateur hour. I'm literally in a chair. It's not really an armchair, but I'm basically an armchair expert. So yeah. Anyway, thank you for watching. I wanted to upload more regularly, but it's like I kind of don't fucking care anymore. I'm doing this more as like a personal diary keeping thing. I'd like to do YouTube, give it like a proper college try at some point in the future, and I'm not going to stop uploading these, but yeah, I guess like creatively, in a lot of ways, in terms of like putting out creative output, like writing and stuff, I'm feeling a little bit demotivated perhaps. So yeah, this has nearly gone for 10 minutes and I don't think I've said anything interesting for like the last 4 minutes, so I'm going to stop now. Sayonara, thank you for watching, and have a good rest of your day.